I've got the honor to introduce four of the best and brightest engineers to talk about standards in a panel called Best Practices and Emerging Technology with Engineering Standards. My name is Bruce Burnside. I work in NAVC in O5S for the Technical Standards Division. I'm going to be introducing four speakers today that will be dealing with these topics. And I think we're going to learn a lot from some of the successes they have had. The first speaker to my left, or be to your left, closest to me, I'd like to introduce Mr. Dan Christensen. Dan works in the Nav Air Syscom. He's a manager in configuration management and data management at the Pax River headquarters, managing that whole activity. Dan has been instrumental in moving various CM standards and documents from the government into SAE International in a single source location. Dan is a voting member of the SAE G33 committee. He's been a team leader in many of the subcommittees that have developed these CM documents and guidance. He's actively involved with cross-Syscom activities and cross-service activities that have successfully implemented the CM portfolio across DoD. The next speaker I would like to introduce is Mr. Jeff Markiewicz. Jeff is a NAVC Syscom employee. He is a subject matter expert, or what we call a tech warrant holder in HSI, Human Systems Integration. He works for O5H, which is Integrated Warfare Systems at NAVC. He also has been very effective driving the HSI standards into a portfolio in SAE International, which he'll talk about. He's our voting member for SAE G45 committee. He's also been involved both cross-service Syscom and cross-service projects. And he actually developed a governance process so that DoD is constantly managing these standards effectively. The next speaker, the third speaker, is not with us today. It's Dr. Dennis Patrone. He's calling in from California. Mr. Patrone supports NAVC with the PMS 406 program, developing the Unmanned Maritime Autonomy Architecture Standards. He's a chief scientist at Johns Hopkins University with APL, or Applied Physics Lab. He is actually the chairman of the UMA committee, which is composed of both NAVC Syscoms, Navy Research Lab, various academic organizations, and some of our warfare centers. So a lot of the stuff that Dennis will be presenting is very new. It just got to be Distro A, so it's kind of hot off the press. So I think you'll be very interested in the success he's having. The last speaker I'll introduce is Dr. Justin Rettaliata. Justin, at the end of the table, is a NAVC employee. He's a subject matter expert or a tech warrant holder for additive manufacturing, or AM. He works in CO5T, which is our technology office. Justin has been very effective at working with cross-service organizations to quickly implement this emergent technology. Not only, I think you'll find that Justin has output a lot of AM manufacturing standards, he is actually driving the implementation, and you'll see it implemented a lot in our ships. So I think the speed at which he's not only got the standards out, but implemented it, I think we can all learn a lot from. So with that, let me turn over the standard experts. I'll start with Dan, and then we'll save questions to the end to save time and ask the panel as a whole. So that, Dan?
Good morning, folks. Thank you very much for the introduction, Bruce, and also the invite to the Defense Standardization Council meeting. Can everybody hear me? Okay. I apologize for not having my email address on there. I think I might have left it off on purpose. I'm not sure. But if anybody wants to get a hold of me, I can give you my actual email address afterwards. It was an oversight. Next slide. First slide, please. The Department of Defense published at one time military standards to ensure defense contractors and suppliers employed consistent and efficient an effective process to conform to government policies. In 1994, Secretary of Defense William Perry issued a memorandum that prohibited most of those military standards. One of those standards was our Mill Standard 973, which was the configuration management standard Bible for all configuration managers within DoD. Unfortunately, it went away. One of the first standards that was created was the EIA 640, ANSI EIA 649 configuration management standard that because of the National Technology Transfer Act of 1966, public law states federal agencies shall use technical standards developed or adopted by voluntary consensus standards or bodies unless impractical or inconsistent. Federal agencies shall participate in the development of those standards. Since then, we've been working on the configuration management standard, requirements, et cetera, and I'll get into a couple of those standards that we've developed. During acquisition reform in the 1990s, in response to the public law, many of the military standards were canceled. But like I said, one of the first industry standards was the configuration management standard, ANSI EIA 649, National Consensus Standard for Configuration Management, which took the place of the Mill Standard 973. Next slide. And I just read that quickly. Next slide. There actually are two standards and one handbook. The SAE, or Society of Austin Engineers, EIA 649C, was updated from the Bravo. It has 40 principles of configuration, or principles of configuration management based on 5 elements of configuration management. Those 5 elements of configuration management are configuration management and planning, which is basically your configuration management plans that program offices develop. You've got your configuration identification, which is your serial numbers, your part numbers, your lot numbers, et cetera. You have configuration change control. You have configuration status accounting, which is essentially your library, your history of configuration changes to your programs, and also the verification and audits. Those 5 elements are listed within those 40 principles of the 649C. It was Tech America before SAE. Before that, it was ANSI EIA 649. The G33 committee, which is the SAE G33 configuration management standard, has a multitude of individuals ranging from Lockheed Martin, Bell Helicopter, Rockwell Collins, Cummings, all the services work with the G33 creating the standard. Now, you'll notice SAEI 649, what we've proposed to the SAE Council is to change that particular naming convention to SAE STD, being a standard, 649C. They're in work on looking at making that change, which would also make the change of the 649-1A, which I was the chairman of the Defense Standardization Council Configuration Management Standards Working Group that created the -1 and the -1A, which is the configuration management requirements for defense contracts. At one time, it was Department of Defense, but we had folks from Australia, Canada, United Kingdom, et cetera, saying if we keep the Department of Defense in the title, they wouldn't be able to use it. So we dropped the Department of and just made it Defense. Those countries are also using the -1A. As I said, I was the chairman of that particular committee. I had about 45 folks that were all military, Army, Navy, Marine Corps, Coast Guard. We had DLA, DCMA, NSA on the committee that created the requirements for contracts. Defense, it's a unique standard to non-government standard, generates management and controlled by non-government standard body. And this standard is for placing tailored requirements on contracts. It goes through and does the 5 elements of CM. It is made to be able to be tailored. If you go in and are in milestone A on a particular project, you want to make sure that you have your CM planning, your CSA information, your shall statements that are listed in the standard on contract. But you don't need ECPs or audits or anything yet until you reach milestone C on that particular contract. What I tell folks, do not put the whole -1A on contract. It's going to cost you if you do. You need to tailor it to those shall statements. I've also worked on the GEI HB 649A, which, as I said, would hopefully will do a SAE HBK 649C with a naming convention. This particular document, the chairman of that particular document was a young lady by the name of Crystal Reed. She is my counterpart at NAVWAR. We created the document. It is 471 pages long. People are kind of scared when they see this document being as large as it is. And what I tell folks, it's your toolbox. For a CM manager, you go in, if you have to create a configuration management plan, you go to the table of contents, you pick what you need, you review it, and you do what it says within the handbook. This handbook actually replaced the Mill Handbook 61A, which was our handbook for CM at the time. Many of the figures that were in the 649A are also in the HB 649, GEI HB 649A. We carry those over. But what I tell folks is, it's your toolbox. When you go out and build a house, you reach into the toolbox and get what you need. You just don't dump everything out on the ground to start building a house. It's for the CM manager's purpose or anybody else that needs to look at how to do CM. There is about 100 pages of FCA, PCA audit material checklists. We created those from NavAir. The only thing different between those particular checklists and the checklists that are in this handbook is the word NavAir. It's the same ones that we use at NavAir right now. Next slide. I call this my bubble chart. You have the 649C, which is the source data for the -1A, the configuration management requirements for defense contracts, and also the handbook. Policy, DoD 5001, 5002, the Defense Acquisition Guide, Chapter 4, also other chapters 2, 5, 7, 12, and 13. There is a new Mill Handbook out there, Mill Handbook 61 Bravo. I was on this committee also that created that. It's the upper level. It's not the same as the Mill Handbook 61A, but it is out there for folks to be able to use for configuration management. There were 6 DD forms that were resurrected when the Paperwork Reduction Act came about in the late 90s, early 2000. They canceled the DD forms. What this particular committee, my Committee of Defense Standard that created the -1, we actually resurrected these DD forms, 1692, which is ECP, 94, which is a request for variance, used to be known as request for waivers and deviations. You've got the 1695 notice of revision, NORS, the 1696 specification change notice, and also the 2617. We also updated 18 repetitive DIDs, ranging from engineering release, ECP, et cetera, and actually there's an additional 20 software DIDs that NavWar created that are updated in the 649-1A for folks to be able to go to. One of the key items that we have on our data item descriptions when you put on contract, for example, for the engineering change proposal, it basically tells a contractor to do one of three things: either use the forms or machine language, which could be Windchill, Team Center, CM Pro, whatever, digital, or for smaller companies, it could be an Excel spreadsheet with the approval from the program office, but the program office basically states that they can use it, but they have to follow the instructions that are written for the particular forms. In the ECP form, we have on the DTIC website, we have pages 1 through 7 as separate files, or we do have a combined file for 1692, all 7 pages, so they can do either one. The rest of them are single pages. But each one of those DIDs for the ECP, the request for variance, NORs, etc., all say the same thing. We made it as simple and standardized as possible for folks to be able to put those particular documents on contract. Then you got also the 15288.1 and .2, and I'll get to that in a minute. And also DAU training, log 2040 has been updated for configuration managers or program offices, logistics, engineering, whatever, to be able to go through the DA training. And one of the things I do want to thank Ms. Butler and Ms. Bond. They were instrumental in helping me get these things through the DOD Forms Manager, DON Forms Manager, and I just want to thank those two ladies for all their help in the past. Next slide. And as I said, the acquirer, which is basically the government, must tailor the 649 in concert with the 649C to leverage the guidance provided in associated handbooks as the GEI HB 649 and the Mill Handbook 61B. These are the front pages of those particular documents. And with this arsenal, they can be standard CM requirements on any contract to be able to pull those shell statements right out and put into a contract, or put those particular shell numbering systems within a contract in order to fulfill the contract. Again, what I tell folks is if you're in milestone A, you don't need to put ECPs on contract. You put what you need to be put on contract, and it needs to be tailored. Next slide. And last but not least, I also was on this particular program, 15288.1 and .2. The .2 is the technical reviews and audits for defense programs. This is an engineering, basically an engineering documents standards. The IEEE, the 15288.1 and .2 can be downloaded on the ASSIST database, but the source data for these particular two documents still need to be procured through IEEE 15288. So in order to know what you're talking about for the .1 and .2, you're still going to need the 15288 source data. And with that, are there any questions? That's all I have. Thank you. Appreciate it.
Thank you.
Good morning, and I want to thank you for this invitation. I think I'm coming through now. I'm Jeff Markiewicz. I'm the Warfare System Integration Manager, Technical Warrant Holder for Human Systems Integration at Naval Sea Systems Command. Thank you for the opportunity to come in. Also want to throw a couple of feedbacks while I've got it in, though I'm here representing what's going on in the HSI standards community. I stand on the shoulders of a number of people who have helped to get us to where we are. Particularly, I wanted to call out Mr. Owen Seeley, who's now working at the Pentagon as a user in the user experience world, who originally had the vision for some of the standards that I'm going to talk about today. and then his follow-ons, Ms. Chelsea Lawson, Barbara DeBerry Kesner, and Ken Robinson, who have all been instrumental, and a legion of people, both at SAE in the contract world or industrial part of the team, and people throughout the Navy and the other branches of the service who have helped to contribute to try to get some of these standards into play. The call out for this was actually a huge boost for SAE when we first got into this. And I'll go ahead and ask if you'll advance next slide. A little bit of what lay out what I'm going to talk about. Some background. I'm going to focus in on 2 standards and an HSI handbook. 2 of those standards are out on the street. The mill handbook is still in final stages of development. We may be, I will hate to say, we might be as far as 6 to 8 months to a year out, depending on course. As I talked about, there's a number of people I work with. The Joint HSI working group is one of them and is taking a look at that. And I'll go ahead and advance to the next slide on background. A little bit of the background. DoD has had HSI policy and guidance, and there have been standards out that cover a variety of aspects. One of the challenges that was recognized, and this is where I point to Mr. Seeley, before I came on board in 2013, is we did not have a comprehensive standard practice to tell us how to do HSI. In addition to that, a number of my Navy counterparts will know Mr. Chris Paquette. Mr. Paquette had sat down with me and talked about the vision about having a handbook available that would basically provide not just information for practitioners, but someplace, a source document that system engineers and program managers, and people who might not necessarily be subject matter experts, could go to as a resource to tell them, how do I go implement an HSI policy, an HSI program in alignment with my acquisition as required by DoD policy. And then lastly, want to talk a little bit about Mill Standard 1472 from a background standpoint. Mill Standard 1472 is a human engineering or human factors. It's actually one of our domain areas. Talk a little bit about the domains in one of the upcoming slides. But recognized, most of you are probably familiar, in 2017, we had 2 collisions in the Navy, well, actually 4 collisions that were recognized. The McCain, most people have heard about, and the Fitzgerald. In addition to that, 2 other ships were engaged in minor incidents. Luckily, we were actually a little bit ahead of the curve on that, and one of the things that was recognized as 1472 was coming up back in about the 15-16 timeframe for its 5-year review was there was not a comprehensive group of standards available to define the bridge. This is not necessarily new technology. It's not that much different than the challenges our aviation counterparts have, but the standard was focused more on ground vehicles and did not have that in. That was something we in the Navy were able to bring in, and the timeliness on that was has been fortunate, as it allowed us a basis to judge the adequacy of bridge capabilities throughout the fleet. Go ahead and ask for the next slide. A little bit more about the people that are involved in. I talked about the Joint HSI Working Group, also the DoD Human Factors Engineering Technical Advisory Group was one of the groups that was paramount in helping them get in 1472 updated. There were probably on the order of about 30 or 40 different people contributing. If those of you have not ever looked at 1472, it's about 200 to 300 pages long, has quite a number of different requirements in it. And we were very thankful for all those participations. Also at the DoD for HSI, like I mentioned, we have a joint group that gets together. They have basically formed the backbone of also the HSI Standards Working Group, which I am basically right now the chair and probably one of the last of the original members when it was formed back in 13, 14. And we have all the service branches and Department of Homeland Security, including the Coast Guard. It kind of brings all of our folks in. The one on the far left is basically the Navy's smaller working group with all the different syscoms engaged and other folks in. Go ahead and next slide. Thank you. I'm probably going to take a little bit of opportunity to talk about human systems integration. One of my pet peeves has been, even within our community of practice, is we don't easily differentiate between HSI, human systems integration, and human factors, or some of the domains. And human factors and HSI kind of tread over it because the people who do one usually are engaged in another. One is more of a discrete discipline, and one is more of a system engineering and technical management approach. Though we've indicated the human factors engineering in the center in many respects, I would probably also argue that these collectively are the different activities and how they interrelate between human factors, training, manpower, personnel, habitability, force protection or survivability, and safety and occupational health. So we are a systems engineering discipline. I will probably be cursed for some for blaspheming in the community, but I do believe if we could get system engineering to fully understand all of the trade-offs, then probably in sometime in the future, my job will no longer be required and system engineers will come in, though I suspect we'll always have a need for subject matter experts to advise them. If I could get the next slide, please. Just to kind of give a little bit of background, that first slide kind of gives an idea of how the different domains come into play in the center one for HSI. And then basically, like I said, as a system engineering discipline, we interface with a lot of different aspects. There's a lot of trade-offs to be considered. We basically spend a lot of our time basically just trying to make sure that the operator and the maintainer, the sailor, the warfighter, the Marine, is properly taken into account when the trade-off discussions are being made in the system engineering community. And I'll take the next slide. All right, I apologize. This is a little bit of an eye chart, but it is somewhat helpful, and it's been helpful for our community to kind of break down the different types of standards that were there and to try to point to some of the gaps that were out there. So for example, starting on the far left, we'll talk about the HSI standard that SAE is published back in 2019. Underneath there, you'll see in the next 3 green boxes, there are 3 other standards that SAE put in, because as SAE was looking at the process, they were realizing that a number of the domains did not have adequate standards and were at least trying to do an initial bridge to lay out some of the different requirements so that the HSI standard could focus on the overall process and not on the specific domains. And we talk about handbooks, data item descriptions, which basically give us direct ability to tie in the contract. I will say, and I don't get too far into it, we did introduce we have about 4 and probably a 5th that we may eventually introduce new DIDs that came out to try and complete the data item description requirements to cover the whole area. And those are still characterized under human factors. And then of course our design criteria manuals, where I've talked about 1472, which is our human engineering design criteria manual for the Department of Defense. If I could get the next slide. All right, probably dive a little bit in. Bruce, can I get, like, I don't know how I'm doing on time, but just give me like a 5-minute heads up when I'm getting towards the end, because I'll talk for a bit. And so the SAE, the current standard, as I said, SAE published the standard back in early February of 2019. After a little bit of, I will say, on my part, trying to understand the process and trying to help others understand the process. Last year in summer of 2021, we basically were able to get DoD adoption of that standard. One of the things that's been a challenge to also explain in my community of practice is just because it's a DoD adopted standard does not mandate its use. And I know Ms. Christensen talked quite a bit about the importance of trying to get those requirements implemented into contracts and specifications. And so that is probably one of the next challenges we have with the 6906 is I would love to tell you a great success story about, wow, we got this on a new program. But unfortunately, with the way Navy data rates go, sometimes the data for the standards comes in and is backdated a couple of years. So it takes a while to get new standards in, but still is out there as a resource into the community to go through. And I think I have Oh, and last but not least, SAE is currently in the process of doing a revision A to the standard. And from what I understand, they're a little ahead of schedule on their 5 years. And I think part of it is to address the new acquisition framework. And I know even last night I was just engaged with some discussion up at the DoD level that we were missing some things with the human system integration framework that was not necessarily covered. And I'm trying to make an argument that sometimes perfect is the enemy of good. We need to take a look at a way of could we get this forward and try to pick up those pieces that are missing and not even implemented yet in a next revision, so that we can get it out on the street. The sooner we get it out, the easier it is to try to get it implemented, because everybody looks at that data date, at least from a Navy perspective, when you're setting a ship specification. Um, I'll take the next slide. Um, scope of the HSI standard practice. It is particularly focused on prime contractor. One of the pros and cons of going with the SAE is number of prime contractors in there. So they tended to look at the world of what will I as a prime contractor be doing. And then I'll talk a little bit more in the standard. And that would be everything from program planning, specifications, the management and integration of the domains, um, risk identification, and one of probably the biggest things was getting a number of shall statements or particular requirements put in. Oh, thank you, Bruce. Okay, I didn't know if that was a 1 minute. Thank you. Is that better? All right. I'll, and some issues on quality control. And I don't know if I missed in the last slide. Also, I know SAE has been putting together a roadshow to try to put together like a 1-day presentation so that they can come in and give a more definitive and in-depth on the standard and how you would apply it as an ability to try to get it out there throughout the community. And I'll take the next slide. The mill handbook. This is still, Navy is the preparing activity on this. We are currently still in development, trying to get through the intermediate reviews. One of the items we've been looking at is, I will say to some extent, there has been some burnout in the community. We're trying to get everybody re-energized, because after trying to get 1472 out, and I'll talk a little bit about the dates on that, we had some drop off in trying to get people engaged. But basically, we're trying to get through all the comments, and we're also trying to tackle whether or not, 5 minute, thanks, tackle whether or not we want to go with the new acquisition framework in this run or try to take it in the next run. And that's being discussed at the joint HSI working group. And Mr. DeLuca, I know, is because we, not in my presentation, is they just got a new HSI defense guidebook, which basically took the place of the old defense acquisition, the DAG, Chapter 5, has been updated. So that is a complement. When we originally looked at the mill standard, the mill handbook, we did not anticipate that that guide was going to be in place. So some of what we're looking at also is we don't want to be overly redundant. We'd prefer to refer, because if I have it in multiple places, when one item changes, I got to go change the other one. Becomes administratively burdensome for the trying to get the standard through. And as I say, I've thrown some dates on this. Depending on which path that we go down on this, I'm hoping either in the spring or the fall to be in or the summer or the fall, be in a position to put this out as a publicated document that goes out and is available for folks to use. And I'll take the next slide. Two of the big aspects that are covered on this is, in addition to basically kind of a how-to on how to do an HSI program, tailoring of the SAE standard, and also basically how is the government to do. There are aspects of HSI that are typically not put under a prime contractor. We want to make sure that they're properly covered. The advantage of having the mill handbook is it gives us a jump up on that as an ability where we can control the content directly in the government, whereas in the SAE, we are part of the team and don't get as much sway on how we put what we put in. I'll go ahead and take the next. Just a few advantages. I think I've touched on most of these. We were originally not, I will say amongst the team, we were originally not we were trying to get a mill standard. We were all liquored up to get a mill standard on the street. Mr. Christensen has talked about some of the realities of that. And we were basically told, look, unless you can tell us that you cannot use a non-government standard, you got to go the non-government standard. So we took that in. Some of the things that we found is you got better acceptance from industry. You get better input. It's far easier to get input in SAE committee. You don't run into restrictions with surveys that we do, and you can leverage much more easily the resources that come in. And using the mill handbook is kind of a good workaround on anything we need to put that's government specific. And I'll take the next one. I believe is 1472. I think I've talked somewhat on it. 1472 was updated in early 2019. It was part of that was because of the collision issues. And I'll also note for anybody who's looking and reading the slides, it says after 201 ship collisions, that's really meant to be 2017, the year. There were not 201 ship collisions that had occurred in there. So, so in order to try and get the bridge aspects put in before Rev H got on the street, we took advantage of the change aspect, injected the section with the bridge, and we're able to get that out in 2019 and facilitate it being used, for example, on the USS Portland to take a look at their bridge, and then for a few other ships in service in the class. The other thing that I want to point out with H is, though this again is not necessarily emerging technology, one of the biggest gaps that we had in the old Rev G was that lighting on the bridge was not fully taken into account. And without getting too far into details, I think we're staying on a distro A, I will just say we did not do the best job of darkening the bridge so that people could preserve their night vision and make the instruments that are on the bridge readable. And that is the challenges as we moved from dedicated analog technology. If you were to look at even some of the old destroyers, they basically had your steering, you had your helm wheel, you had your throttles, and basically a lot of discrete dials and such. Now it's all touch screens, and if you don't have those touch screens with the ability to have the proper level of dimming, which is different on the bridge than it is in CIC, because CIC does not have to preserve night vision or the Combat Information Center. So that has been a huge change. And because of that getting on the street, we've been at least able to put mitigation kits out with the destroyers, and we're looking to integrate those out throughout the fleet. So it's been a boon to try and get those things in. And I'll go ahead, and I think this was the last slide. And I don't know if Mr. Christensen did this on purpose, but I did put my email and my phone number in. I will throw a caveat in that there is a perishability with that. It is not to be running off, but basically after Halloween of this year, I don't anticipate working for the government anymore. So my counterpart will be taking my place. And I believe we're holding questions off until the end. So I'll yield the floor. Yeah. Thank you.
Yeah, thank you, Jeff. Appreciate it. So the next presenter, Dennis Patrone, is online. Do we have him connected? Can we do a voice check?
Yeah, audio check.
Hey, Dennis.
Hey.
Go ahead.
All right, thanks. Yeah, so I'm Dennis Patrone. I apologize for not being able to be there with you today, and thanks for the opportunity to speak. As Bruce mentioned earlier, I'm the chair of the board defining the Unmanned Maritime Autonomy Architecture, or UMA. And today I'm going to talk about what UMA is, why it's important. I'll talk a little bit about the structure and the organization defining UMA, how UMA relates to and builds on other standards, and then wrap up with a discussion of some of our products and processes. Next slide, please. So what is UMA? Well, UMA is a standardization initiative from the Navy's Unmanned Maritime Systems Program Office, or PMS 406. And at its very core, UMA is a set of government-owned interface control documents, or ICDs. And these are software-based interfaces that define the exchange of data and control between components within an autonomous system. And so by having these well-defined standard-based ICDs, the goal is that we can encapsulate hardware-specific concerns, enable portability of software-based components, and ultimately support competition across industry for specific components and capabilities rather than always contracting a full integrated system, which is costly. Next slide, please. So this next series of slides are an attempt to visualize the motivation behind UMA. So 406 has a growing number of platforms. Some examples are shown there on the left. Each vessel has a different set of hardware, different control mechanisms, and so the control for each vessel is unique. The mission level autonomy, that's that cloud in the middle that basically controls the platform, needs to understand the setup and control of each of those vessels to work in different environments. And the same is true for payloads. Different sensors, different mission-specific payloads have their own data, have their own control protocols. And so every time we bring a new one of those in, we also have to go in and touch the mission autonomy code. That ends up being a very costly endeavor because there's a lot of work being done to put these things onto vessels in terms of certification, cyber considerations, things like that. So every time we have to go in and modify code, we're adding a lot of cost and time to the schedule. And then again, there's a number of C2 command and control systems out there, and we have to work with each one of those. And so you end up having this n times m times r number of permutations, which is not sustainable. And what really ends up happening is we end up picking probably one of each. And then those blue, green, and purple lines, you build a purpose-specific autonomy for that unique combination. The issue is if I build some really great capability into that mission autonomy and now I want to take it to another vessel, well, that's a significant development effort because of all of those platform-specific controls or payload-specific controls that are embedded in that cloud. Next slide, please. So hopefully you can see where we're headed with this. Right, the idea is to generalize and encapsulate those differences across the platforms and payloads and C2 systems behind those standardized interfaces to reduce the complexity of the integration. So instead of mission management sending a specific CAN bus message to actuate a controller to move a rudder, it just commands the boat to turn to a specific heading. And then behind that interface, on each of the specific vessels, there's code that's responsible for turning that high-level control into the appropriate messaging in their specific environments. Beyond the encapsulation of the hardware, there's also a lot of software-based utilities that are often re-implemented each time these new systems are developed. And that's shown in the middle of the slide in that stacked green set of services there. So what we're really trying to do is to standardize those services so that we don't have to redevelop them every time, and that different mission autonomies can make use of standardized mapping charting services. That's things like where are the buoys, where are the bridge pylons so I don't run into them, or communication controls so that I can get information back to the C2 system. So all of that not only reduces the cost and the scope of the mission level autonomy development and provides us that level of abstraction so that we don't have to change it, but again, the idea is to reduce the time, the cost, the schedule impacts of bringing on new payloads or moving autonomies onto new vessels, because a lot of that code that now has become standardized and encapsulated behind those interfaces has already been tested. It's already gone through the certification. It's already gone through the cyber constraints, and so it's a much smaller surface that has to be investigated to get approval to move these systems around. Next slide, please. This slide just shows some notional services grouped in the functional areas defined by UMA. Given that we're more interested in the standardization effort, I'm not going to spend a lot of time on this. Next slide, please. So the scope of UMA is limited to the autonomy system running on the USVs and the UUVs. That's that red dash line around those vessels. While some of the data might be shared with the C2 system or other cooperating manned or unmanned vessels, UMA's not working to find those interfaces. Our scope is strictly limited to providing the services that reside on a single vessel to support autonomy doing its job and completing the mission. Next slide, please. All right, so now that we've talked a bit about what UMA is and the motivation behind it, let's jump into how it's organized and gets defined. So UMA has an interface control working group, and that's that big light blue box in the center of the slide. That is the organization that defines and maintains UMA. The activities are coordinated by the UMA board. I'm the chair of that. We have representatives from 406, different Navy labs, ONR, UARCs like Johns Hopkins, that's where I'm from, Penn State ARL, Georgia Tech. And we take direction and provide support to the PMS 406 program office. We defined the architecture principles, the conventions, the governance, compliance, all of those types of things for UMA. And our work now is following all of that guidance that was developed to define what services are in UMA, what are the operations associated with those services, and what data comes along with those operations. When we define that for a service, that information is provided to the specification working group. These are the people who turn that board direction into the real specification. They're generating the actual ICDs and IDL documents that are the output that define UMA. And we'll talk about that process in a couple slides. So the output of the SWG, one of the places it goes is to the Reference Implementation Working Group, or the RWG. So that group prototypes just enough of the specification to identify gaps. So they're looking for, given where are the standards ambiguous, where are there required operations that we haven't defined, are we in conflict with other parts of the standard? So they work through some of those issues, and there's a feedback loop between the SWG, the RWG, and the board to make sure that we're generating a good standard. And at the same time, the SWG is providing their products out to industry. So they're working in a DevOps pipeline, and we publish that out to a site where anybody in industry with the proper authority can access it and access it immediately. So that's really providing industry the ability to monitor the evolution of the standard and provide immediate feedback as we're developing it. To give us better information, right? We are not working under the illusion that we have all the answers and we're doing everything perfectly correct. We're looking for that industry feedback to come in and let us know what we're missing. And then finally, we aren't building these systems in a vacuum, right? The reason we're defining the standard is to support the programs that PMS 406 is developing. So there is an interaction with representations for the different platforms and missions that are in development to make sure that we're also addressing their gaps or ambiguities that they're running into within the standard. And those interactions kind of complete the feedback loop and really help to direct the prioritization and the work that the board is doing in defining what's next. Next slide, please. So, UMA wasn't created out of thin air. We're building on standards that date back to the 1990s. In the interest of time, I'm not going to step through them, but just to say, the first three standards are kind of build on each other, and UMA is continuing that tradition by building on kind of the output of that lineage. And then that last standard, the OMG DDS, that's a middleware specification for pub sub software architecture. It's a bit of a different class of standards than the first three. But UMA is using it to define how the data is formatted and exchanged among software services and components when they do need to communicate across the network or between software process spaces. So we are building and learning from the efforts that came before us. Next slide, please. All right, so now let's get down into the sausage making and show how we're actually building on these related standards. So UMA development is broken into two phases: the platform independent model, or PIM, which is the top of the slide, and the platform specific model, or PISM, and that's the bottom of the slide. So the PIM is intended to capture conceptual information, things like I need to know the position of the platform or where the contacts are around me, while the PISM is how those concepts are actually represented in code, right? That's like a position is a 32-bit float that is a latitude and a longitude in degrees and a depth in meters. So we can generate many different PIMs given the same, PISMs given the same PIM. So given that these are all just mappings from the same PISM, there is, at least in theory, a knowable translation between different PISMs, right, the bottom of the slide, built using the same model, the same conceptual information that we need to share. And that's extremely important when we need to communicate with the C2 system. So I haven't talked about it, but we are coordinating with the Common Control System, or CCS, which is another 406 initiative, to develop a common interface for operators controlling these vessels. Because Autonomy needs to share information with the C2 system, like where we are and what's around us. We ultimately need the data on the vessel to align with what's being manipulated on the C2 system. And having this shared common model ensures that alignment, but it also allows CCS to define their PISM separately so that they can address their unique software development, requirements and environment that they're operating in. All right, so starting with the UCS specification, which is that blue box at the top, that's a binary representation of the PIM. MDE then is a series of add-on updates to the data types, operations, and services, and that's all defined in JSON. And JSON is just a parsable text format. We have a tool called UX SDK, and that reads that JSON and updates the binary model with our changes. So we're extending on UCS. We're using the UCS MDE, which is one of those standards in that hierarchy from the earlier slides. And then we're adding in our own modifications to that model that support UMA. All that comes together through UX SDK that spits out the new UCS MDE model that includes our information. There is that gray line feedback that ultimately the intent is for the UCS MDE to feed our updates back through SAE, which manages the external UCS specification. But we aren't exactly there yet. We have provided some feedback to them, but their timelines, as a large international organization, their timelines are, an order of magnitude slower than what we need for our early stage of development, right? We need to be agile. We need fast turns. There's also releasability concerns that have to be dealt with. So what we generate up front has to be distribution D, and then we need to go through that slow review process to get it released as distribution A, so that we could provide it to a external international standards organization like SAE. That just adds cost and time to our timeline. So we're working to eventually get to that place, but in the interim, while we're kind of storming and forming, we're trying to make sure that we have the ability to quickly turn on our updates. Given that model, the UCS MDE PIM, we then feed that down to create our PISM. And again, ultimately, this becomes a set of PDFs that are the ICDs that describe what the services do and how they operate, as well as the IDL, which is actually machine readable code that is required by the OMG DDS to allow the exchange of the information that we have specified in UMA. So the way that gets generated is we have a set of templates that define what we want those ICDs and IDLs to look like in a general sense, right? For any service, this is what we need to generate. For any data type, this is what we need to generate. We run that through the UX SDK tool again. This time, instead of updating the model, we're actually reading from the model and applying those results to our templates to generate what ends up becoming the output that defines our standard. Next slide, please. So this is just showing some of our products. At the top, we've got a series of documents that govern our architecture design principles, how we're managing the standard, what it means to be compliant with UMA. In the middle is really that UCS MDE model that we're generating. Again, we generate that as a separate product because that gets fed off to the CCS effort so that they can build off of it as well. And then finally, the real output of our standardization efforts, right, which is the ICDs and IDLs that define the interfaces that we're working with. And then that last, stacked reference implementations off of there. This is really the only software that UMA is providing. If you recall, we talked about the RWG that's doing some prototyping on some of the services and the standards. That code is also made available to industry as examples so that we can help bootstrap them into the working standard. But ultimately, UMA proper is not providing software. What it is providing is the specification of the interfaces between software. Next slide, please. So this is just intended to show UMA is not a one-shot definition. We think of the ICDs as buckets of capability, and we will define new services as we fill up those buckets. Some of those buckets already have more content than others. Some we expect the buckets will be much larger than other buckets. And this is just the idea as we need to continue to evolve the standard as the needs of autonomy and the way that 406 wants to procure these different capabilities evolves. Next slide, please. So this shows our release process. It's kind of an eye chart. I'm not going to spend a lot of time on it, but our development environment was shaken up recently, so we've fallen out of this schedule as of late. We're working to reestablish the drumbeat, but ultimately the concept is we're generating through our development cycle a distribution D version that goes out to industry with proper access. And then, as that's being released, we put it into a distribution A review pipeline to get that out. And so we have a trailing, older version distribution A. We've been through that once. That distribution A version is available on the AUVSI website. AUVSI is a nonprofit organization for advancing autonomous systems across different domains. And so that is out there. Again, it is at least a couple iterations behind where the distribution D is, but it's out there. We have a newer version in the distribution A review pipeline, but we don't have proper approval to distribute that yet. But the idea is we're going to continue to try to disseminate these ICDs as far and wide as possible, in the interest of supporting adoption. Next slide, please. We do attempt to have regular industry participation by hosting industry days. Prior to the pandemic, these were in-person events, and that's an image from one of them, with a lot of back and forth and direct feedback from industry. Recently, we've gone virtual. And if it's, since it's difficult to have remote meetings with 250 people talking at the same time, they've largely become push-based events where we're presenting where we are without a lot of feedback from industry. Industry still has the availability to submit tickets to us through our ticket tracking system, and those are addressed by the board. So all the data flow isn't just one way, but it isn't as real time as it was pre-pandemic. And as the impact of COVID wanes, we are considering how we can evolve this critical part of industry participation and maybe get it back to something that's a little bit more back and forth. Next slide, please. So I mentioned our ticketing process is one way industry can provide feedback and recommendations to the board. It's also what we use internally to track our own work. And I'm not going to step through this flow chart, but it's just to show we do have a well-defined workflow that we follow when addressing tickets. Different states, have the responsibility of the board or the SWG or the RWG to do the work. This has really worked well for us, and it allows us at a glance to quickly understand where a ticket is in its life cycle and who's currently responsible for moving that ticket forward. Next slide, please. So, where's UMA today? Our last release was, 5.2 back in April. Again, normally we would have had another release by now, but as I mentioned, we're migrating our development environment, and that's interrupted our normal development cycle a little bit, and we're trying to get back on track. We're raising the bar for making changes to the existing interfaces. A constantly evolving standard isn't really a standard. So we have this conflict between continual improvement and stable interfaces. So we're looking to see what we can do to be responsive to those changing needs and minimize the impact. And part of that effort is to understand the impacts of these proposed changes to systems already in development and under contract for 406, and at least make sure that we're making informed decisions about when we should, make, or when we can make non-backwards compatible changes. We're working with another group for 406 called the AFWG, Autonomy Framework Working Group, to bundle these services together into components. So something that we've learned, as this process has evolved is, UMA services are the building blocks for software systems. And what's a good size building block for a 6-foot UUV is not really the right size building block for a 150-foot surface vessel. They're just different scales of development, different scales of integration. So we're working to support these different scales using the same sets of services, but just grouped in different ways. And that's part of the ongoing work. That's a collaboration between the UMA board and the AFWG. And finally, we're working toward our next industry day, tentatively late fall 2020. So stay tuned for that. And with that, I will turn it back over to Bruce.
Excellent. Thank you, Dennis. So, Justin, I'll let you.
Good morning. I'll stand up and give you something to look at and move around so we get our eyes moving back and forth, because we all know, and as I joke when I go and do the technical talks with our teams, whenever I talk policy and standards and specs, you watch them slowly droop down. But this group should raise right up and get really excited, because this is our lifeblood, right? So, more than all, I'm Justin Rettaliata. So I'm the tech warrant holder for additive manufacturing. I've been in the position 7 years this year, and came on board with a blank slate on how do we build and adopt this technology that really had very minimal governance, and we had no means of really adopting and seeing how we wanted to move it forward and where it could be used. We knew it was cool. We knew there was a push from CNO saying we should start using additive manufacturing. So how are we going to do it? And I was stupid enough to say yes to the position. So I got the bag and I got to start figuring it out. So it's been really interesting trying to figure out, what do you do when you don't have good structure around it? So what kind of structure do we have to build in order to enable the technology to flourish, but at the same point, not hinder it so badly that it's unusable, right? So that was an interesting balance we had to come through. You can go to the next slide. So I have 65 slides. I'll base them down into 3, just for their case of time. But best way to do this, I wanted to start off and just give you an overview of what today's additive manufacturing program looks like, right? So we break it into 4 swim lanes. Number 1, dear and hearts of mine, is tech authority, right? So how do we govern the technology? What kind of specs, standards, structure do we need to put in to define how we get these components, these systems, everything integrated into shipboard use, right? So end use components, systems, that type of thing. We have a float program, an expeditionary program. So we use these in labs day in and day out. We understand how these systems work when they're in a controlled environment where, it's not being shaken, it's not being rattled, it's not being rolled, it's not, the temperature swings are non-existent, that type of thing. So now when we start putting it into a dynamic environment, what starts happening to these systems? What do we need to start looking out for? What do we need to understand so that we can start providing some sort of governance to structure it, right? Digital integration. Additive is a digital technology, right? Much like CNCs and everything else. There's a file that you have to have in order to make the part in the end. What does that start looking like? So how do we bring it through? How do we integrate these things into our networks? So what kind of standards or requirements do we have to get these things plugged into the networks? Because a lot of these are cloud-based and that type of thing. So what kind of, hardening do we need to do with the systems? What kind of hardening do we need to do with our networks in general? We're working on establishing digital environments, where you basically create a room, for lack of a better description, where you can put these systems, and then that room plugs into your network, right? And that's a sea-based or a shore-side type capability. The next, and this is where the rubber really hits the road, is supply chain integration. So I can have all the governance in the world. I can tell you I can print everything under the sun, but if I can't get it into our supply system, how do you really get the technology to grow? So understanding what are the requirements of the supply system, how do we use the supply system to give ourselves parts today, right? So when we used to do outreaches early on, and Additive was very much in its infancy, people would look at you kind of with a third eye and say, hey, this is Star Trek Replicator, you can't make this. Or they would look at you and say, hey, here's a refrigerator or a microwave or a microchip that I can't procure or get. So can you make that for me, right? So it was, we weren't using the systems like we could best utilize, right? It's because we have logistics, we have obsolescence issues, we have requisitions where we can understand where are these, what parts are getting pulled down and manufactured. So how do we start using the systems and then integrating the systems so that we move forward? Go to the next slide. So when we look at products of Tech Authority, so I had to establish some semblance of structure for the program and for how we were going to adopt it, right? So first started off with what was originally a design practice and criteria manual that proved to be a little too immature to go out as a formal manual. So it came in as an ABC guidance letter signed out by, at the time, Rear Admiral Selby, the chief engineer for 05. And this walked through what approvals do you need? Who needs to do the approvals? What kind of materials go on board? What is the tip to tail that you have to follow in order to allow a part to go on board a ship today? We started looking then into how do we start governing the processes. So AM is 7 different processes. We concentrate on about 3 to 4 of them at NAVC. There's powder bed fusion, where you're scraping micron layers of powder over a build plate and lasing it and making it with that, and you're building it from the ground up. There's directed energy deposition, which is essentially a MIG welder on the end of a 6-axis robot, right? Building up, very crude. You have material extrusion, which is your polymer type systems, where it's the maker bots of the world that you all see, and those can do polymer and metal. And then we have binder jetting, which is essentially take a sand, put glue where you want it to stick, don't put anything where you don't want it to stick, shake it out, and you get a form that way, right? And that's both for indirect, so you can print cast molds, or direct, where you're printing kind of a sintered metal and you have to put it in the heat treating oven and build it that way. So when you start looking at the different processes, what kind of governing documents do we have to do? So we looked at mill standards. I looked at standards bodies, right? So we are in partnerships with SAE, or we have people on boards of SAE, ASTM, AMSE. I was part of the ANSI kind of road mapping that went to identify gaps for industry standards for additive, right? The problem was it took too long. It took too many opinions, and the standards that were out at the time were pretty generic. So what ends up happening, as we got these published, ASTM had published the aerospace standards, the AWS D20 committee had put stuff, but when you started looking at it, it lacked the specificity that we needed for NAVC, because what they do is they say upon what is agreed upon between vendor and OEM, right? So it's kind of a catch-all, which is fine. There's nothing wrong with that, but that takes what I refer to as negotiations going back and forth to come to an agreement, versus we wanted to take a more specific role and have our needs better described, right? So when we look at it, we did tech pubs, which are good that we have full control. The downside of tech pubs is it's hard to broadcast them to industry, right? You can't Google a tech pub and it pops up, right? You need access to a government site like TIDMIS to access these, which makes distribution of these very difficult. So when I stand up in some of these forums and I ask people if they are aware that we have technical guidance and requirements for AM, I'm at a solid 50%, which sucks, right? Because people want to use the technology, but then you're like, well, we have governance. They're like, where? I'm like, email me, and I do provide emails, just not phone numbers. So when we look at the standards that we've put out, the tech pubs, we put a tech pub for powder bed fusion that was released early 2020. We put a tech pub together for wire arc directed energy deposition. I specify arc because there's different power sources. You have electron beam, you have laser, you have arc. You then have powder blown laser, DED as well. So how do you start writing these standards to address the different processes, and then how can you start blending those together, right? So do I want to have 50 different tech pubs that govern AM, or can I start bringing them down into 2 to 3 that are more concise? We're also establishing ones for polymer, right? So for material extrusion, so when you start printing more critical parts that might have weight bearing or go into more critical systems versus your brackets or your clips or your knobs, right? What do we need to start looking into? And so there's a framework for that, looking through what we need to do and move. As we start looking at the guidance today too, just to bring it back there, we're hitting a point of maturity. So the guidance was released in 2018. It's long in tooth. I was supposed to update it yearly. We're still on Rev 1. I haven't updated it yet. So next move is, how do you start turning it into something that is more actionable via a contract? So DPC that ship has sailed. I don't think that's the right way. Again, working with Chris Paquette, because he seems to be the godfather of, you sit down and say, what do I need to do? He'll sit there and explain 10 ways of how you shouldn't do it, and then 16 other ways of how you could do it, and then you figure out between, right, what the right way to go. So we're going to push for a tech manual that will allow us to have more of a official document. It will be the motherhood document for NAVCAM, and allow you to then reference the different tech pubs that go under it, so that you now have one place to look. It'll tell you what you need to do for, if you're an industry member, if you're a organic capability, a regional maintenance center, or a shipyard trying to manufacture something, or if you're Sailor Joe on a ship that needs to go print something, assuming the capabilities are out there. The other aspect of this too, in addition to governing the processes, we have to develop tech data packages for these types of things. So beauty of additive, it's digital, right? But if you don't have the right data included in your tech data packages, what I print on the East Coast will not necessarily be the same thing I print on the West Coast. We had work with DLA before where they sent a part out. Simple, it was a bracket. They sent it to 3 different OEMs. They came back with 3 different parts, and neither one of them were correct. Right. So how do you start governing these things, and who do we start working with to integrate these, and what kind of partnerships do you need to get into when you're working through that? Go next slide. Oh wow, I really kept it short. So, but so the way we tried looking at this has been an interesting journey as we look through how we adopt and get the technology moving. Right. So this is required moving and working across multiple domains. We're working across Navy from an executive level all across the SysComs. We're working with DIA or Army. We're working with Air Force. We're partnering with defense logistics agencies on how do we start standardizing this so there's some commonality between the different entities, so that we're not all going our own different ways, right? As things start maturing and the standards, the ASME, ASTM, like those standards keep maturing more. One of the things I'm starting to look at too is, hey, if we have a company that's qualified to ASTM XYZ, what do I need to look at in my tech pubs so that I don't have to make you requalify it? But how do I start making my standards flex so that if you're qualified to this, you need to do steps 1, 2, and 3 in order to meet our requirements without having to go through full requalifications. So as we start pushing that, this is kind of the game that we play going back and forth. I have information in the backup. I'm happy to talk more technical and kind of give you more background on how we go to. Yeah. What these last 3 slides kind of walk through, 2 slides kind of walk through how we structured the documents, right? So when you look at the guidance, it was who should be involved, what kind of risk assessments do we need to start looking into and doing, what kind of polymers. For this one early on, we didn't know, or the materials that we would put on board were going to be polymer initially, right? What makes this technology or the materials very amenable to print makes them fail horribly for fire, smoke, and toxicity. Which means I have like 10 other warrants I get to go work with. As Jeff can attest to, I am one of 239 of my closest friends. So it takes a small army to get something on board a ship. It doesn't mean it can't be done. But there's a lot of boxes that got to be checked and a lot of people that got to approve, right? Because, I'm the guy who's supposed to be an inch wide and a mile deep, but there's other folks that are owning platforms, they own the systems, they own the components, right? So there's a lot of different things that you have to work through when you look at what does it take to approve something. What I do like to point out is this doesn't touch anything in the reactors. Anything I say does not apply to our naval reactors, folks, or any of our nuclear weapons or any of that stuff, right? So those are one of the things I made sure to always foot stomp when talking through the guidance. You can go to the next slide too. And then when we do the technical publications, what we're starting to do is come up with a standard format as you work through these, right? The general thing is, hey, we need to, if we really dumb it down, it's governing the feedstock, what's going into the machine, what the machine is capable of producing. So what kind of material can that machine produce and what kind of tests do we need to do to ensure we have some sort of statistical understanding of it. And then how does that translate into building the actual component? So there's component verification. Because the technology, the geometry or the way that the part is oriented and the geometry of the part will change how its material properties are, just because of the heat inputs. So if you look at a build, if you powder bed fusion, for example, if you have 4 parts on a build plate, you take one away, the material properties are now different than the 3 that you left, just because of the heat inputs, the tool pathing, everything. So it's a welding process. So how do we start governing? So that's why there are a lot of different moving parts to how we do this. I think that was the last one. Oh, there it is. That's the best one. That's what everyone wants. So, good here.
Thank you, Justin. Can we give the 4 experts a round of applause, please? Okay. So I think we have about 10 minutes for questions. I know we have some questions. Should I start online? You want to?
Right. I have one question online for Dan Christensen. Much of the contracting activity for configuration management relies on data deliverables. Who will be managing the DIDs for those?
Managing the DIDs is the program office's data manager, and in NavAir, it's the configuration and data manager. But we have what is called a DRRB, Data Requirements Review Board, that reviews all seadrils and associated DIDs before it goes on contract. So they facilitate those, but it's whoever requires that deliverable, whether it's logistics or engineering, is the one that's requesting that. And then we research that in the assist database. I have a data manager that researches that for them, or it could be a one-time DID within the command. If you have specific deliverables that you need and it's not in the assist database, we grant one-time DIDs to a program office to be put on contract. But then I also ask my data manager to research to see if it become a repetitive DID for all of DoD.
How about in the audience? Anybody else have a question? Go ahead, Mr. Elber.
My question is for Jeff. Mill Standard 1472. There's also ASTM F1166. Do we still want to use that at all? Do we only use 1472? Do we use both?
That's so I think that the answer is had a few discussions with Daniel Wallace. As Justin pointed out, we have lots of other tech warrants we deal with. Daniel Wallace is ultimately the warrant for that. His short answer for that is his preference is usually 1472. I will say I would love to tell you that he and I know the length and depth of. So I think the short answer is sometimes both. Right now, I've seen on a number of ships where we use both. For bridge and pilot house, 1472 right now, obviously big advantages on that. That's where we know there's an advantage. There are some pros and cons. 1166 has some things it covers better, like whole body vibration, whereas 1472. So there's ultimately, and this kind of goes back to, in an ideal situation, instead of just saying, "Hey, we're going to do the entire ship in accordance with 1472 or 1166 or some breakup," because most of them now say 1166 with 1472 for the bridge, and if there's a conflict, it gives the priority. Ideally, we would have laid out and said, hey, these shall statements come out of 1472. These shall statements come out of 1166. So I don't think 1166 is going away. But I'll say when you get into, and I'm going to get the word wrong, when you get into human measurements, anthropomology. Thank you. I'm not great with the cocktail words. But they tend to be more updated. But I know Daniel and I have been engaged with ASTM when it comes to 1166. So they're trying to make sure that both of those standards are fairly up to date with the, with similar approaches.
Thanks.
You have I guess a question or a comment for Justin, maybe some more thoughts on. I'm intrigued when you mention the flex requirements. Like why do I have to go through steps 1 through 10 when I can do 3? Like we had a similar thought on that for what we're doing in the material space. Yeah, just a thought. It's from like an engineering perspective. When you have boots on the ground, it's like intuition. It's easy for me to overqualify something, and it's also easy for me to set a minimal requirement on a part. It's hard to get in between. So our thoughts on it was why we wanted to run our performance spec on a database platform was to use active learning and an input back from your technical data packages to get statistical confidence on those in between decisions, which seems to me to be particularly applicable for additive manufacturing. So you can overqualify like that build plate there for something for flight, or like you can make something where you're not concerned about like a kid's toy, on your, but that no man's land in between is difficult. So have you thought out any, what's your approach to tackling that problem? Thank you.
Yeah, so the issue with additive is I can print a doorknob or I can print a reactor coolant pump. So the range, and that's really difficult. So when we looked at building the standards, we literally had that landscape. So it was really difficult for us to kind of identify what requirements are necessary and then how do we start approaching and applying them, right? So the way we went about it was a risk-based approach. So the NAVSEA has a 1 through 7 because we like to add extra blocks onto our risk matrices, ranging from you sunk my carrier to you caused, and it's a cost, right? So sunk my carrier, $1 billion deficit or damages, to the 7s and NAs, it did about $50,000, $100,000 worth of damage, and no one was injured, right? So loss of life to minimal injury. So what we started doing was implementing under like a 1 through 5 range is when we require the technical publications. So you have to use the technical publications when you do that. After that, under that, there's going to be component-based testing that has to be done, but there's no like formal qualification required by the machine. The other issue is additive machine shops are generally, you have trades, you have people who are going in and they know how to run the machines and they work them right. There's a paradigm shift with additive manufacturing about who is purchasing machines and who is running the machines. So I could have my former captain up in OpNav used to refer to as Joe's bait tackle and 3D printing shop. So you could literally you almost have to write these standards for the lowest common denominator. So when I have folks like GE who have that data you're talking about that are, thousands of coupons they've broken, statistical, everything, they can relate every machine back to this pedigree data to Joe, who thought it was a great investment, had $1 million from mom and dad, bought a machine and started running it and is looking for the business case on how to make it work. So that doing it to the lowest common denominator frustrates the people who know what they're doing to no end, and they're very vocal with that about me, with me about that. But at the same point, we have to watch out for kind of how we're doing. And it's not that I always look at our tech pubs as a line in sand, not chiseled in stone, right? Because there's negotiations that we have to be good business about this too, right? The issues with the powder bed as it sits now is it costs you about $500,000 on top of purchasing the machine to qualify it. You're making 300 plus coupons and everything else. And what I forgot to mention is we literally issued that in January of 2020 and the DED one in May of 2021. Rev 1s are out at the end of this fiscal year. We're already revising them, trying to figure out how to make them better because they're the first shot, right? And there's things as the ASME case codes come out, as the D20 committees come out, and there are things that we can glean from, and again push through quicker because they're ours versus having to get a committee to vote on them and kind of work the basis back that way.
Frank, you had a question?
Yes, this is for Justin as well. And I guess part of it you might have already addressed, but I'm concerned about what Sailor Joe is doing during deployment. So, and you mentioned tech pubs, right? So, and I know I'm going to overly simplify this. You got raw materials, you got a machine, and you got an end product, right? And so typically when we're buying a product, all that stuff is done by the manufacturer. And we're just taking it and saying they did their job, or the assumption is they did their job and this product's going to work. Now we're shifting it to Sailor Joe and a tech pub. Is there a quality, I'll say quality standards being developed? Typically tech pubs are more process driven and not testing and verification. So it seems like there's certainly areas where things can go wrong. And you mentioned about, and I know it's a complex question, right? Because a lot of things are tied to this. Qualifying a raw material and potentially qualifying machine. That's great. When I get that machine and I start using it day one, now I'm 6 months into a deployment, or maybe 2 years later, and that equipment's still there. Is that equipment still qualified? And how does all that work for quality conformance at the end? So that's it all comes back to the part and quality, and is there a quality standard for testing and verification?
Remember when I mentioned I was stupid enough to say yes to this position?
Well, but
no, that's
great. About Sailor Joe.
Yeah, no. There is a fear of what they do. So when I talk about our float program, we have 8 official, I stress the word official, installs on surface ships and 4 official installs on submarines. When we did one of our first installs, and I had engineers out at Puget for getting Stennis spun up, they told him that Sailor Jimmy had the printer in his rack on third deck kind of thing, right? So there's whatever they're making with the polymer. It's okay because there is logic in that if I'm replacing a metal part with a polymer part, that it's not the same thing. No offense to Marines out here, there's a joke that's not necessarily fair for the Marines, because if it physically fits it works and off they go, right? But again, they don't sink, they don't fall out of the air, they just stop on the side of the road because the truck stops turning, right? So there's a little bit, that's where I go back to the risk. When we talk quality control, we're starting to talk about training. The people that get the installs, there's training that our engineers give them and get them up to speed, right? So there's things to look out for. When we talk tech data packages, there's fit checks, that type of thing. But again, these are all low critical parts. So a dimensional check and you're good, right? Because if it fails, it's safe to fail. When we start, we still have not worked out how that's going to work for more critical. This fall, we will be putting a metal printer on board a ship. So we are starting, we're giving them tech data packages to do this, right? So if you start looking at oh yeah, this is fun. I love my job. This is, but this is, I mean, yeah, oh, they know. Yeah. But again, so NavAir, that's actually a good comparison. So NavAir, where they looked at and they did additive manufacturing, you can only put on an approved tech data package, period, right? There is no riffing off of that. There is no changing it. It has to be that printer or, that material, that type of thing. So, and they've gotten a lot of the parts that are out there that can be printed on board ships, because NavAir is putting printers on ships too. polymer. So those are safe to fail. So they don't really care about what part or what material you're using because they're safe to fail. But as we start putting the metal ones on, that's where, it does get a little trickier. But yeah, for air, you can only put on an approved TDP. For the seaside, if we can help fix the ship, that's good. What I also tried doing with the guidance was lowering the approval. So they're still like when the printers go on, they're under the authority of the chief engineers on board the ships. So they own the printer. So they have to do sign-offs on the parts, supposedly. Again, there's only so much I can control from, here when they're all, it's.
What we do is have a green, low, class 2 change.
Yep.
Blue, class 1 change.
Yep.
And it has to be the program office's approval.
Yep. So, and we have the same risk basics where we have our green box parts and then you have your blue box parts, but it's not that binary, right? Because there's levels of blue, and that's Naviator has a 1 through 4. We're essentially the same thing, right? Your green safe to fail, your blue box level 1 risk 2 for them is a no structural requirement, but there's material requirement. So it has to be rubber, it has to be something else. Then has a material requirement and a structural requirement, so it has another step of risk, and then it's the full Monty. This is locked down. There's one printer in the NavAir that's allowed, or NavC that's allowed to print it, and any derivation has to do approvals. So.
Okay. Yeah, can we go a couple more minutes, Michael? Time check. Okay.
And before you take a question, I just want to go back to Mr. Alberstein's question, because my answer is a very Naval Sea Systems Command specific answer. 1166 typically only applies to nautical marine systems. So once you get outside the realm of that, the Navy and the Coast Guard, in shipbuilding, you're probably not going to be looking at 1166, and you're going to be looking at 1472. So Army is probably going to tend to be more, and I'm sure in the air they may even have other standards that I'm not fully aware of. So just wanted to throw that caveat in before somebody went out and said, Jeff said this. And thanks.
Bruce, I do have one from Mr. Hepfey. When I briefed Mr. Welby, he was not there. Mr. Gold was there back in 2014, just before the -1 was approved for publication. One of the major things that we talked about at that time was being able to procure the standard. Most of my program offices don't have a budget in order to go out and procure. And what they did at that time was what Mr. Gold asked is each one of the services to provide $4 million each in order to go out and put on contract through the Library of Congress, through FedLog, in order to purchase these standards, not just CM standards, but engineering standards, et cetera, et cetera. Where that came about, it was $16 million. The ROM went out, it went up to 28 million, and nobody wanted to fork up the money. At one time, there was a plan to POM for that funding in order for anybody with a CAT card to be able to go out and get these. That's one of the biggest problems I have with the program office. We're not going to go out. They can borrow my copy in order to get, shall statements, but they just don't have the capability to be able to purchase all these standards that are necessary. And now going digital, how are we going to be able to fund that?
Yeah, it's an excellent question. We tried palming multiple years, have not been successful. That dollar amount we found has fallen above what's changed that we can collect, right, and then pick up somewhere, and not high enough of an impact to pass through. So we're now looking into and looking for opportunities to grab a smaller collection, maybe work with one service or agency and start small and build from there. I think that's our best path to eventually achieving that enterprise-wide access.
Right now, I can get an account through IHS to go out and buy standards at $25K per person. But if I want to go out and get the CM standards, it costs me less than $800, $900. Okay, so I don't do that. If I need to, I've gotten my copies, being the chairman, past chairman, that people can be able to use. But most of the program offices, CM managers say, how can I get a copy? I can't put my copy on KMS site because of copyright rules. So I can have them come and get my copy and look at it and, write it down, whatever. But I can't post it for all 34 program offices to be able to use. And that's just CM standards, not just engineering, the IEEE or whatever. Something, we got to be able to go out and purchase these standards if we're going to be able to use them.
Yeah, I completely agree. Yeah, and thank you for bringing up the point again. I do want to give credit to each of the services and to DLA, who have just they've taken tremendous strides in the past few years to consolidate access and contracts for access to standards within the components. And I think in the end, that will make the job easier for establishing enterprise-wide access. But I think until we get to that complete, and until we get to the CAC-based access, we're always going to have offices, field